We are having one topic. We have discussed hysteresis. See, what is hysteresis? What material? It can be a paramagnetic also. Okay. What we do? We place it in a variable magnetic field. A variable magnetic. We can increase or decrease the magnetic field direction also. Suppose what we did. It is intensity of magnetization, magnetic intensity. It was magnetization intensity and it is magnetic intensity. You remember all these those two values? Now see what happens if suppose what happens, magnetic intensity we are increasing here. What will happen? Very few material will get magnetized there, very few. They will start magnetization. Okay, what will, when we are increasing H, their intensity of magnetization will increase and it will follow like this. After some time it goes to saturation, that we are increasing the magnetization, intensity of magnetization, that is magnetic intensity, and the intensity of magnetization is getting fixed, saturation. Okay, and we say this point as saturation point. What is happening this point? Suppose I say it as it was 1 point and say it as 2 point. At 2 point, what is happening? It is happening that all the magnetic dipoles are arranged here. In this case, at one point it was random and it started arranging themselves along the direction of magnetic field. Okay, what happened at some point? Let us point 2. It get aligned along the direction of magnetic field. Okay, now what we do? We decrease the value of this magnetic intensity. We are decreasing the value of this magnetic field. What will happen? This dipole will get disturbed now. They will start de-alignment. Their de-alignment will start. They will get disturbed. They will de-align themselves like this. But what we see, one interesting fact, that when we decrease the magnetic field, it doesn't follow the same path that we are decreasing, but it follows this path like this. See here, at this point we have kept the value of magnetic intensity as 0. See here, at this point we are decreasing the magnetic intensity. What happened? We decrease the value of magnetic intensity like 0, but we see that some value of magnetic intensity is also retaining there. It is retaining here. Let us see. It is O and I say it as A. Some magnetic intensity is present there. In spite, we have kept the value of H as 0. We have reduced the value of H to 0, but some value is retaining there. So we say OA point as retentivity. What? Retentivity, or we say as remanence. Okay, this much value is present here at H is equal to 0. Now we got confused that some magnetic property is remaining there also. Now we want to decrease the magnetic property. What happened? Now we changing the direction. We changed the direction of this magnetic intensity. Now earlier it was from left to right. Now we change the direction. What happened? That in this, the magnetic intensity direction external we have changed. What will happen? The material. See what will happen in the material. We are decreasing as such that we have changed the direction also. What will happen? This will get more and more disturbed. After some time, what will happen? Their magnetization will get diminished. No magnetization will remain there. All will become random and the magnetic property will become 0. Okay. After some time, we say that at some value of negative H, we will see that intensity has become 0. Let us see. Let us say this values as B. OB point is called as OB is called as coercitivity. We say that coercitivity. That is the point where the coercitivity, the point where negative magnetic intensity we have applied, and we got the magnetic intensity as 0. We have applied the negative magnetic intensity and we got 0 intensity of magnetization at this point. After that, if we are applying that negative intensity and increasing it, what will happen? The dipole will get aligned according to this magnetic intensity direction, and they will get aligned like this along the direction of magnetic intensity, and they will go to saturation like this. Okay. Suppose again we are increasing in opposite direction, changing the direction, what will happen? It will follow this path and it will go like this. What we see? We see that we started from this, go to saturation, then we decrease. Here we got the coefficient of retentivity. After that, again we are decreasing the changing direction. Here we got 0 intensity of magnetization. Here we call coercitivity. After that, again we are decreasing and changing the direction of magnetic intensity. Here we got saturation point. Again we change the direction. Then again we see that it follows the path like this. And the area under this loop is so the loss. So our intensity is that to get a minimum area. So we say that the magnetic material which has this much very thin in hysteresis loop area is very good for our electromagnets. Okay, so this is our hysteresis concept, and you should remember 2 points here. One, I have explained all those points. One point you can see here, the area under this curve shows the loss. Area under this loop, what does it show? It shows the losses. Okay, now it shows the losses. Now let us see what is happening for a permanent magnet. For if we want to make a permanent magnet, for a permanent magnet, what we need? We need that OA, that retentivity should be high and coercitivity should be high. For electromagnet, we need that OA should be less and OB should be less. That is, retentivity should be less and coercitivity should be less.